Emissivity and Absorptivity for Different Colored Paints by Tyler Ogden and Orson Callister. We wanted to explore the effect different paint colors have on emissivity and absorptivity values. Black and white paint have been well documented, but other values for other colors are hard to find sometimes. We wanted to see where the other colors fall in comparison and the variation between the emissivity and absorptivity. Spray paint was used to paint pieces of cast iron that were roughly 5 by 1.5 inches and a half inch thick. These pieces were used because they were something that we had on hand from a previous project. Initial testing was done with 3 pieces of cast iron to see if the emissivity and absorptivity values could be evaluated. The chart on the left shows the temperature change as the specimens were heated in the sun, and the chart on the right shows the temperature change as they were cooled at room temperature. The greater difference in temperature between the black and the white paint during the heating process show that there will be a greater difference in the absorptivity values than the emissivity values. The line in the middle was a plain sample that was also used in comparison. To further explore the absorptivity, more colors were used and the specimens were placed out in the sun to be exposed to thermal radiation from the sun. Starting from a uniform temperature of 24.8 degrees Celsius, the temperature was taken periodically over a 25-minute period until we thought that the temperature had settled enough that it wouldn't be increasing. Over the 25 minutes, it became evident that the different paint colors were affecting the temperature of the specimens. The piece painted flat black reached the hottest temperature after the 25 minutes, reaching 42.6 degrees Celsius, while the one painted white only reached a temperature of 36.2 degrees Celsius. All of the specimens heated faster during the first 10 minutes than the remaining 15. To explore the emissivities of the paints, the objects were heated to a uniform temperature and then allowed to cool in a room at room temperature. The data for cooling did not come out as well and pretty as the heating data, but it does appear that the cooling takes more of a linear trend. As expected, the emissivities appear to not be as spread as the absorptivities of different colors. We wanted to see if the absorptivity values have a proportional relationship to temperature difference. The equation shown on the right was used, where T reference was the temperature of the reference specimen at a given time. Alpha ref is a known absorptivity value. Ti is the temperature of the specimen that is being evaluated at the given time, and alpha I is the absorptivity value of the specimen being evaluated. Flat black was chosen as a reference using an absorptivity value of 0.98 because it's a well-known absorptivity. A similar method was used to calculate the emissivity using the equation on the right. Using the relationships previously discussed and flat black as a reference, the following emissivity and absorptivity values were calculated. All of the emissivity values were greater than 0.9, with a range of only 0.069. As was expected, the white paint had the lowest absorptivity value of 0.827, with a difference of 0.153 from the reference value. We noticed a pattern with the absorptivities in relation to the spectrum of visible light. The colors with longer wavelengths seemed to have a lower absorptivity, while the colors with shorter wavelengths had higher emissivities. It would be interesting to do an experiment again using colors that are spread throughout the color spectrum to see if there were truly is a relationship between wavelength and absorptivity. Some conclusions and recommendations that we had. We expected to see lower absorptivity values and aren't sure why they weren't lower, showing that the proportional relationship we used may be invalid and there may be a better way to evaluate the absorptivities and emissivities. We don't know if the roughness of the cast iron played a part of the thickness of this and the thickness of the spray paint made a difference, but we think they may have. If this experiment were to be repeated, we recommend that an infrared imaging camera be used to measure the emissivities of the samples, as this would be much easier and likely more accurate. Something that we also thought could be considered would be to use more of a consistency in paint, whereas some of our paints were flat black and some were glossy, and we had a metallic gold paint in there, and it might be better if they all had the same kind of finish, as that may have an effect on the experiment.